Hi guys, we're continuing with roots and radicals. And in this video, we're going to introduce also some variables underneath the radical sign. So the first video was all numbers. This one's going to include variables. Before we can talk about variables, we need to talk about when you need to use absolute values on a variable. So with numbers, we can really control whether we want to write them as a positive or a negative. But with a variable, since the variable could equal anything, we don't really know what it's equal to, we do have to sometimes force it to be positive by using absolute value bars. Now, there's only one scenario where you have to force a variable to be positive using absolute value bars. And this is called the even, odd rule. So in the original problem, if you have an even index, and the exponent on your variable is also even. And then when you go to write your answer, you have an odd exponent. Then you need to enclose that variable in absolute value bars. Even, odd. Even index, even exponent, odd answer. Throw some absolute value bars around that variable. Now, every variable needs to be treated independently. So if you have multiple variables in a problem, you do need to check each one individually. Sometimes multiple will be inside bars, sometimes none of them will, sometimes only one and not the other. So just really pay attention to when you need it and when you don't. Here's an example of when I do need absolute value bars. Now, this one's a little bit confusing because I really only see one number in it. I just see the number 2. So let's put in our invisible numbers. This problem has an even index because it's a square root, so there is an invisible 2 here. It has an even exponent, and in my final answer, it has an odd exponent, right? The number 1 is invisible, but if we write it in there, we can very clearly see this follows the even, odd rule. So I would throw some bars around that letter X. Even, odd. Here's an example where we would not need to use the absolute value bars. So let's talk about why this one doesn't need it. We can draw in our invisible index, which is a 2. And so on this problem, I have an even index, an even exponent, but an even answer. So since my answer is not odd, I don't need absolute value bars on this one. Here's a shortcut on how to deal with variables and exponents on these problems. So to find our answer to this question, you can divide your exponent by whatever your index is. So you can write out 4-letter X's and circle them in pairs and have some get out, or you can just do 4 divided by 2. And that's where I got this 2 from. Okay. Here's another example where we do not need absolute value bars. The rule is even, odd. And this problem is odd, and then another odd. So as soon as I saw that I had an odd index, I don't even think about absolute value bars anymore because they're not gonna exist in this problem. And again, the shortcut for this one, it's the exponent divided by the index. So in my head, I did 9 divided by 3, and that's where this x to the third came from. All right, let's try a big problem with like numbers and variables. All right, so let's try this problem. So I'm going to take my 128 and I am going to do a factor tree, get it down to its prime factorization, which turned into just like a whole bunch of 2's. Now, again, for your variable, you can do 7 divided by 3. It doesn't go evenly, but that's okay. If you have a remainder, then those will remain inside of your radical sign. Or if you're a visual person, you can write out your 7-letter X's. Make sure to pay attention to your index in this chapter. So this is to the index of 3, which means I'm looking for 3 of a kind. Okay, so I'm circling in triples, not doubles. So I have my 3 2s. I have another set of 3 2s. And this leftover 2, it doesn't get to belong in a circle. And it's going to be left inside the radical. And then the same thing happened with my letter X's. I had 3 X's, I had 3 more X's, and I had a leftover 1. From each circle, one of them will get out of the radical sign. So a 2 and another 2 and an X and another X. And everything else that was circled, you cross out. Those are no longer part of the problem. And anything that's not in a circle stays underneath the radical. And so since two 2's got out, I have a 4 here. 2 times 2 is 4. Same thing here. Since two x's got out, I have an x squared. Or 7 divided by 3, it goes in twice with 1 left over. And the 1 left over is the one that's left inside. And then here's that 2. Make sure that your new radical has the same index as your original radical. That's one of the most common mistakes that I see is we have a tendency to just write square roots always for our answer, but this was a cube root. So it does still need to be a cube root. And for this problem, we double check and it's an odd index. So I'm definitely not going to need the absolute value bars. But this one was odd, odd, even. Odd index, odd exponent, even answer. So no absolute value bars required. Why don't you pause the video and check and see if you can do these problems and pay very close attention to if you need absolute value bars or not. All right, let's check your answers. So on the first one, I only need absolute value bars around my letter X and not around my letter Y. So I do have an even index. So I have even, and odd. 2 is even, 6 is even, 3 is odd. So my X needs the absolute value bars. Now I don't need the absolute value bars around the Y. The Y was even, and then even again. So it was missing this odd part. So that's why the Y is not inside the absolute value bars, but the X is. All right, for question 2, don't need the absolute value bars. If we look at the letter X, I have an even index, right, even, but then I have an odd exponent. So I'm missing this even. So don't need them. As soon as you hit a word that's not in that even, odd, you don't need to worry about your absolute values anymore. So even, odd, and then this is technically odd, right? Even, odd, odd. It's not even, odd. So no bars required. And then on this one, since the negative was outside of the radical, then your answer is just a negative. It's not a imaginary answer because the negative was not inside. On our last two problems, both of my indexes are odd, so I don't even have to worry about absolute value bars. When you have an odd index, you never need absolute value bars. And so here is the answer for number 3. This 3 right here is the index on my radical. It is not an exponent on the y. So you might even want to space those apart a little bit when you're writing them down so it doesn't look like y to the third. So it's very obvious that that 3 is the cube root. And then here is our answer for number 4. And there was nothing left over in number 4. We talked in the first video, when you have an odd index and a negative, then your answer is just negative. So remember, imaginary is only for even indexes. This concludes all of our videos for today.